Example 1, the population growth of a colony of cells is growing so that it triples every hour. Suppose the current population is 10 cells. How many cells will be present after 4 hours? So we have to model this problem with an exponential equation first. And we have to define what the variables will represent in our equation. So to help us define the variables, you're always going to look at what the question is asking you. The question is asking us to find the number of cells here, how many cells. So that will always be what y represents. Y will represent what you're looking for. So we can write let y represent the number of cells. And if you continue reading the question, we're asked to find the number of cells that will be present after 4 hours. So look at the units. Okay, so the number of cells depend on the number of hours that go by. So that's what x will represent. So let x represent the number of hours. And then since the cells are growing by tripling, we know that this can be modeled with an exponential equation of the form y equal to k a to the exponent x. So we just have to fill in numbers for k and a. K is the initial number of cells present. So it says the current population is 10 cells. So we're going to sub in 10 for k. A is the growth factor. It's how the number of cells are growing or multiplying. And they're being tripled, so we're multiplying by 3. So in place of A, we're going to put 3. So this is the equation that models this scenario. Now if you want to find out the number of cells, y, present after 4 hours x, we just sub in 4 for x. Evaluating, we get an answer of 810. Therefore, 810 cells will be present after 4 hours. Okay. Let's look at another example. It says the hydrogen isotope tritium is radioactive with a half-life of 12.5 years. A sample contains 35.2 units of radioactive tritium. What amount would remain after 25 years? So this is a radioactive substance. Every 12.5 years, its mass is reduced by 1/2. That's what half-life means. Okay, so for example, let's say I have a substance that has a half-life of 5 days. And if I look at the mass of this radioactive substance as the number of days go by, you will see that its mass is reduced by a factor of 1/2. So if I start with, at 0 days, a mass of 100 grams, after 5 days, I would only have half of that left. If another 5 days go by, so a total of 10 days, I would only have half of 50 grams left, so it'd be 25 grams. Okay, if another 5 days go by, so a total of 15 days, I would have 12.5 grams left, and so on. Okay, so this is what half-life is. For this radioactive substance, tritium, the half-life is 12.5 years. So every 12.5 years, mass is cut in half. Okay? It says, what amount would remain after 25 years? The question is asking us for the amount. So y is going to represent the amount of tritium. X in this case is going to represent the number of half-life periods that go by. Or the number of half-lives. since mass is not going to be reduced by a factor of 1/2 every year, it's going to be reduced by 1/2 every 12.5 years. We have to see how many half-life periods it takes for it to be reduced. Okay, so now we're going to write the equation that models this scenario by subbing in numbers for K and A. K is the original amount of the substance. So in this case, we have 35.2 units of tritium. A is going to represent our decay factor because the mass is decreasing or decaying. Okay, so we need to figure out what we're multiplying by each time. So if you look at this table here, okay, we're actually multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2 if you think in terms of fractions. So we're multiplying by half. Half of 50 is 25. Half of 25 is 12.5. So for all half-life type problems, your decay factor is going to be 1/2. Now that we have the equation that models this scenario, we can determine the answer. X represents the number of half-lives. So how many half-life periods are in 25 years? So how many times is mass going to be cut in half if it's cut in half every 12.5 years for a period of 25 years? So 12.5 goes into 25 2 times. So mass is going to be cut in half or reduced by half twice in a 25-year period. And then we would evaluate using our calculators, giving us an answer of 8.8. Okay, therefore, 8.8 units of tritium would be left after 25 years.